Hello everyone. The next section we're going to cover is Chapter 6, Section 3, and we're going to continue our work in solving inequalities. This section is called Multistep Inequalities, which just means we're just going to keep working on using properties of equality, addition, subtraction, multiplication, division. Only this time we're going to add in the distributive property, so each problem that we solve it will require in general more than 2 steps. Okay, let's get going. Here on this very first example, we have 4x plus 6 is less than or equal to 54. As always, we go to the unknown, go straight to the unknown, look what's around it, and we're going to undo everything around it from the bottom of PEMDAS up. Okay, so we've got add 6, we've got multiply by 4. We're going to undo that addition first. Whatever we do on one side, we've got to do on the other. And our symbol here, our inequality, stays the same. And we will subtract 6 from 54, which will give us 48. And finally, we'll undo this multiplication with division, and we have x is less than or equal to 12. Now, to solve, we did not multiply by a negative, nor did we divide by a negative. So our inequality symbol is going to stay in the same position. We're going to go over to the number line, and we are going to fill in our dot because we can be equal to 12. And all of the numbers that are less than or equal to 12 are going to be going to the left. Okay. And on to example 2. This one looks quite a bit more complicated. As always, when we have a fraction in front of a sum inside of a parentheses, we want to undo this fraction first rather than use the distributive property. Although, in this case, I guess we could. But in general, I've been teaching you to go ahead and get rid of that denominator. Now, since this is a negative here in front, I'm going to multiply by -3 just to keep everything positive over here. And consequently, I'll have to multiply by -3 on this side. Now, when we multiply by a negative, I'm just going to write it here. When we multiply by a negative, we have to switch that inequality symbol, the direction of it. So multiply by negative. Over here, these are now going to cancel, and a negative divided by a negative is a positive. So if you want to, you can continue to put that 1 out there, but it's really not necessary. And again, I'm going to make it a different color here. We're switching this less than symbol to a greater than symbol because we multiplied by negative. And over here we have -6. And I can use the distributive property, but 1 times x is just 1x, and 1 times 21 is just itself. So really I could just rewrite this, and I didn't really even need to put the parentheses there anyway. Okay, and so we go to the unknown, we see we're adding 21, so I'm going to subtract 21. And x comes down, our symbol, we've already switched it, opposites cancel, and we have -6 minus 21, which is going to be -27. So we're going to go to -27 right here on the number line, right at this point, and I cannot be equal to -27. I can only be greater than, so it is an open circle, and all the numbers that are greater than are going over here. I'm going to write it right over here, to the right. Okay, taking a look at our next example here. -5w minus 2 is greater than or equal to 23. Go to the unknown. We're subtracting 2. We're multiplying by -5. We're going to undo the subtraction first. And the -5w comes down. Opposites cancel. And we have 25. And w is being multiplied by -5, so we're going to undo that multiplication with division. And notice we divide it by a negative. And that is one of 2 cases where we have to switch that symbol. So we've got these canceling, and we have W, and I'm going to change that greater than or equal to less than or equal to. And a positive 25 divided by negative 5 is negative 5. So we're going to go right up there to our negative 5. We're going to fill in the point here because it can be equal to negative 5. And all the numbers that are less, remember, the more you go left, the smaller the number. So this is W less than or equal to negative 5. Okay, next we have a pretty simple problem here. We can use the distributive property, and we get 2y minus 4 4/10 is greater than 0. Go to the unknown. We're being multiplied by 2, and we're subtracting 4.4. So I'm going to add that 4 4/10 to both sides. And that 2y just comes down. Opposites cancel to 0. And we've got our 4.4 coming down. And we're going to do our final division. And notice we're dividing by a positive 2, not a negative 2. So we can just leave our inequality symbol the same, and we've got 2.2. Now let's take a look at this number line over here. How do we determine the scale? Well, it might be easier to just highlight here the major numbers. I'm a little bit offset there. So we know 2.2 or 2 2/10 is going to be somewhere in between 2 and 3. How many spaces? Count the spaces we've got here in between. We've got 1, 2, 3, 4, 5. So we've got one whole number, that would be the difference between 2 and 3, being divided by 5 spaces. So if we look at that, let's take a look at that. One whole number being divided by 5 spaces. Of course, 1 cannot be divided by 5, so that's a 0. And I'm going to subtract that, bring down a 1. I have to keep this decimal here, this place value going. So I'm going to bring up my decimal here, and of course 5 goes into 10 2 times. So each one of these divisions here is 2/10. So if we look at then where 2 and 2/10 would be, we'd be right at this first tick mark, we'll call it. And the numbers greater than are going off to the right. Now, I've purposefully left that circle open and not filled in because this solution set is greater than 2.2, but not greater than or equal to 2.2. Okay, third example here, we've got, quickly you can see that we've got variable terms on both sides of this inequality, and we've got numbers on both sides of this inequality. So we've got to get the variable terms together and the numbers on the opposite side, and it doesn't matter in which direction we move, but we just have to get all of the like terms together. I'm going to choose to make this positive here, so I'm going to add a 6p over here. Of course, those opposites are going to cancel. Now I have positive 6p minus 1p, or minus 1p plus 6p. That's going to give us a positive 5p plus 6 is less than or equal to negative 4. Now we have a multiplication of 5 and an addition of 6 around our variable, and we're going to undo those. Bottom of PEMDAS up. So 5p comes down, opposites reduced to 0, and negative 4 minus 6 is negative 10. And we're going to do our final division. 5 divided by 5. And they cancel, and p is going to be less than or equal to negative 2. Now, is this answer over here negative 2? Yes, it is. But we're not going to switch this inequality symbol because we did not divide by a negative. Only when you divide by a negative, or if you multiply a negative to solve, then we would switch the symbol, regardless of what the sign is over here. Okay, so let's go to negative 2, and I'm going to fill in that circle and all the numbers that are less than -2 are going off to the left. Alright, in our final example, we're going to have to free up this term here, both these two terms I should say, out of these parentheses. So -3 times 2x is -6x, and a -3 times a -5 is +15. And we want to get the x terms together and the numbers together. Now just for variety, I'm going to decide to move this 6x over here. And again, only because I want to keep it positive. But you could have moved just as easily this x term over this way. It doesn't matter. And I've got the 15 coming down, -13, 1x plus 6x is 7x. Now I'm looking over here. I want to undo the operations around our unknown. I'm not going to be subtracting 15 over here. I want to get everything over away from x. So keep that in mind here. So we're going to undo this subtraction first. And we've got 7x. I'm going to rewrite this over here. And I'm going to undo this multiplication with division. Again, it's positive, so I'm not going to change my symbol. Now remember, if 4 is less than x, 4 is less than x, then x is greater than 4. So if you want to just make sure you're going in the right direction. I know a lot of you like to just say the arrow goes in whatever way this symbol does, but that's only in the case as if your variable term is over here on the left and here it's on the right. So just be careful with that. Okay, thanks for listening.